Molecular geometry. VSEPR theory, 6 electron domain molecules. In this tutorial, we will be looking at 6 electron domain molecules with the octahedral geometry, specifically looking at examples of sulfur hexafluoride, bromine pentafluoride, and xenon tetrafluoride. Let's look at our first example, sulfur hexafluoride, SF6. Sulfur hexafluoride has 6 electron domains. 6 of the electron domains are single bonds between the sulfur and the terminal fluorine atoms. There are no non-bonding electron pairs on the central sulfur atom. All bond angles are 90 degrees. The electron geometry is octahedral, and the molecular geometry is octahedral. Our next example is bromine pentafluoride, BrF5. Bromine pentafluoride has 6 electron domains. 5 of the electron domains are single bonds between the bromine and the terminal fluorine atoms. So 1, 2, 3, 4, 5. One electron domain is a non-bonding electron pair on the central bromine atom. All bond angles are 90 degrees. The electron geometry is octahedral, but the molecular geometry is square pyramidal. Our final example is xenon tetrafluoride, XeF4. Xenon tetrafluoride has 6 electron domains. 4 of the electron domains are single bonds between the xenon and the terminal fluorine atom. So 1, 2, 3, 4. 2 electron domains are non-bonding electron pairs on the central xenon atom. So 1 electron pair here and 1 electron pair here, and these electron pairs are represented right here and right here. All bond angles are 90 degrees. The 2 non-bonding electron pairs are located above and below the equatorial plane to minimize repulsion. The electron geometry is octahedral, and the molecular geometry is square planar. So what did you learn in this tutorial? We talked about 6 electron domain molecules, the octahedral geometry, specifically examples of sulfur hexafluoride, bromine pentafluoride, and xenon tetrafluoride. Need more help? Feel free to contact me. Have a great day.